I touched on this a little bit earlier. The similarities between capital budgeting and asset valuation. The, so when both cases, you're going to estimate the cash flows expected from the project, or the cash flows expected from a stock or bond. Uh, the Evaluate the riskiness of those cash flows. The compute the present value of expected cash flows. Obtain an estimate of the asset's value to the firm. The same process with a stock or a bond. With a stock, those cash flows are unknown. Bond, they're certain, but we're still discounting what either we think or know those cash flows are going to be. Then we compare the present value of future expected cash flows with the initial investment. If the present value of the cash flow is greater than the initial investment, we'll purchase the asset. Same with a stock or bond. If we think that there's value there, if the value is greater than the initial investment, we'll invest. So NPV simply is the sum of the present value of all the future cash flows. So the CF0 is the initial investment. That's an outflow. Then we take all the future cash flows and they present value those by the required rate of return. So the cash flow in year one is present valued by 1 plus the required rate of return to the first power. In the second year, 1 plus the required rate of return to the second power. But the decision rule project is acceptable if the net present value is greater than 0. So we have 2 projects here. We've got projects S and L. They both last for 4 years. Initial investment are the same. However, project S has cash flows earlier in year greater cash flows in year 1 and 2, and then project L has greater cash flows in year 3 and 4. So project L is back end loaded, even though the cash flows for project L are greater, because depending on what rate of return we're using, project S has a good chance of being more valuable to the firm because those cash flows occur earlier. So these are just the cash flows on a timeline. So again, we can see that project S is front loaded, project L is back loaded. So in this case, project S, our net present value, with a required rate of return of 10%. So our $1,500 cash flow in the first year, so that's 1,500 divided by 1 plus 0.1. So that's $1,363. 1,200 divided by 1.1 squared, 800 divided by 1.1 cubed, 300 divided by 1.1 to the 4th power. So the cash flow function in your calculator will do this. We'll go through those in the problems, but it's second cash flow and then second clear. You always want to clear it out, but you would in this case, this would be, I'll go ahead and write it out. This would be CF0 would be 3,000. The C01 would be the 1,500. C02, C03, C04. We did NPV and we'll make I equal to 11. Go down to NPV and hit compute. And that's going to tell you that NPV is equal to $161.33. So Project S would be acceptable to the firm because the NPV is greater than 0. Project L, so the Project L again, so this is CF0, cash flow 1, C02, C03, C04. And again, same process. You would enter each of these in those register after entering the cash flow function. Second cash flow, second clear. Set I equal to 10%, and then go down to NPV and hit compute, and it's going to tell you that in NPV of in this case Project L is $108.67. So if we were picking between S and L, we would prefer Project S because the NPV is slightly higher, $161.33 versus $108.67.